Practical SQL Server 2012 Administration and Programming, Select Statement, Exploring CTEs, Nested and Correlated Subqueries. CTE stands for Common Table Expression, and this is how we define it. This is the actual query. Changing the database context and rerunning the query. So this query we define as a CTE for later use in another CTE. The CTEs can be nested and or in the main query. In this case, this is the main query. We only use it in the main query. We can redefine the result list from the select, execute. Let's execute the next query. In this one we have a CTE with inner join, where clause, and group by aggregation. And in the main query we have a different group by, and this is the result. CTEs can be nested, so first CTE is sequence 1, the second is sequence 2, and it uses sequence 1, and so on. So let's execute to check the result. And this is the result. We get a sequence. Till 256, which is 1 byte 8 bit. In the following query we use a recursive CTE, and this is where the recursion is taking place. CTE serial number. Let's check it out. And this is the result set. If we go back to into the past with the base date, when we will generate the months, the beginning of the month for each month, all the way to the present date. In this query, this is a subquery, and this is a nested subquery. Let's execute it. In the following query, the subquery is correlated, and we see this is the correlation. This is the alias for the inside table, and E is alias to the outer table in the main query. Let's execute it. The query yields the sales staff with $5,000 bonus. In the following query we are using select and aliased as a column. So this is a correlated subquery. In the following query we are formatting the date and currency. In this instance, we order date. And we are using the brand new t-sql Server 2012 format command to format the date and also to format the currency as well. Proceeding to subqueries with a comparison operator. So this is the comparison operator and this is the subquery. We have an order by clause as well. To locate vendors without purchase, we do a not in operation. And we can also use the any, all, and some operators with subqueries. This is the any and this is the sum. Execute. We return the same number of rows. And this is all. We return 5 rows. And exists. Return 33 rows. Not exists if correlated subquery. This is the result set. And this query has 2 plain subqueries. This query will list all the products which have the same price as BB ball bearing. We can do the same operation with a join. We got 199 rows. And again we got 199 rows. This is how we use a subquery in an exist or not exist conditional. We are dropping the table only if it exists. This way we are not going to get an error. If the table does not exist, then we are not going to drop it. So let's reposition to pubs. So execute, and it executed. Let's create the table with select into. And check the database metadata. Sys.object. And it exists. So if we execute this statement again, it's going to drop the table this time. And the table is gone. We got an empty result set. This is a correlated subquery, and pub ID refers to the column in the current titles table, and publisher's pub ID refers to the column in the outer table. which is the publishers. So these publishers publish in business. We got the same result set. And we are looking at the royalty. And using a correlated subquery again. Our shading was not right, that's why we got the error. Another correlated subquery using the all operator, set operator. We are listing the authors for popular computing type of books, and this is the list. In the following query, we organize the data in a CTE and then pivot the data to get layout by columns for employees, for 5 employees. Execute, and here is the result. So we pivoted the data from rows to columns to get a report. In this query, we are using a group by summary CTE and join the CTE with our tables to get the final query. In the following query, we are pivoting by quarters, and we selected the order date year as 2007. This query uses 2 CTEs and joins the CTEs with a person table, and this is the result set. We create 2 tables, very simple tables, and populate the tables with a few rows. Execute, and we do a CTE to do recursive processing, and this is the result when we execute the query with recursive CTE. We can use correlated subquery for running total calculation. Now this may not be very efficient. We can also use self-join instead of a correlated subquery. This may have a performance issue as well. Recapping, with CTEs, subqueries and correlated subqueries, we can structure the SQL code and achieve real sophistication in querying the database. The CTEs are especially useful for structured programming because we list the CTEs at the very beginning in a structured way, and when the main query becomes rather simple and easily readable. correlated subqueries are used to get complex results from the database, because the database itself quite simple. The data is listed in table formats, but to get complex relationships out of a simple looking data, we can use correlated subqueries. The CTEs support recursion as well, so we can do tree processing with recursive CTEs. This is the end of the unit.